Welcome to the Data Hall YouTube channel. In this video, we are going to talk about how do we create portfolios in Stata and how do we then calculate the portfolio returns. So what we are going to do is we are going to discuss the xstyle command, which would generate portfolios. So there are multiple types of portfolios. We can either do one-dimensional portfolio or two-dimensional portfolio. Then we would look at percentiles or deciles to make portfolios, and we will look into how do we calculate equal weighted portfolio and value weighted portfolio returns. If you want to download this do file and the attached data, the sample data that we are going to use in this lecture, do click on the link given in the description. So let's import this data. So what I have is we have a couple of firms. So these are firm IDs. Then we have data for different years. We have market capitalization, the book to market ratio, and stock return. So you can form portfolios pretty much on any kind of variable, but market capitalization and book to market ratio is related to firm and French factors. So I'm just going to use these two. So we are not going to exactly mimic the firm and French factors. Rather, I would just give you a basic idea of making portfolios. So if you think that we need more lectures on that, do let me know in the comment box below. Okay, so that's how the data looks like. So what do? We use the xstyle command to create portfolios. So how this works is that we use the egen, which is extended generate command. So we generate a variable, let's call it xstyle underscore portfolio 1. That would be equal to, so this time we are going to use xstyle as a function. So we write xstyle, and then within the parenthesis, we give the name of the variable. And after comma, we use the enqueue option where we state that we need 10 deciles. So these are the number of portfolios that we want to make. So it would construct 10 portfolios based on market capitalization. So let me just execute this and let me show it to you. So it has created different portfolios, and you can see that we have 10 portfolios. Let me just tab xstyle portfolio 1. So that tells us that in each portfolios we have 33 observations except for the last one. So the idea is to we use the extended generate command to create portfolios, and we are using the xstyle function. But remember, xstyle is also a command, so we can directly use this as a command. The way it would work is we would use xstyle, then we would give a name of the variable, then equal to sign, and then we use the market capitalization, because on the basis of market capitalization we would generate, and the rest is the same. So if I execute this command, it would give you the idea that both, whether you are using the generate command, the extended generate command, or xstyle is a function or xstyle is a command, that both gives you the same results. And just to prove this, so we are going to count if xstyle is not equal to this temp variable, which is coming for the command xstyle. Okay, so we need to remove this space. Okay, so we missed the if modifier. So there are no observations where they both are different. So they both are same. So what I meant to demonstrate is whether you use it as a function or as a command, they both generate the same result. But there is an added advantage of using xstyle as a function. And what is that? Now, In this scenario, what we did is we generated portfolios based on market capitalization. But rather in most of the research papers, they do not do that like this. They generate portfolios for each year. So at the end of each year, they would generate portfolio. So what we need is we need to loop through each year and use the Xstyle and generate portfolios within each year based on market capitalization. So for that, we can use by sort year. Now, this by sort is not allowed with when you're using Xstyle command. But when we are using the egen Xstyle as a function using the egen command, then we can use by sort. So if you want to do this by sort certain variable, so you'd have to use the egen command. So that is the advantage of using this rather than Xstyle as a command. Okay, so let me execute this command. This is the same command except that now I'm using by sort year. So for each year I want to generate portfolios, and at the same time I'm just changing the name of the variable. So it gave me an error, and the error is that unknown egen function Xstyle. But that error, although the wording is different and it doesn't make sense, but the issue is that even with egen, when we are using Xstyle function, we cannot use by. So certain commands, certain functions are not buyable, right? So we cannot use by with certain functions. So what we do is there's a way around. There is an egen more command. It is a user written command, so you'd have to install it. And when we install this user written command, we can use by sort with every function of egen. Okay, so the command installed, and now I'm going to execute this command. These both are exactly the same commands. So now if I execute this, you see that although the error didn't make sense, but the issue was that we needed to install egen more command. Okay, so what it did is that it generated a portfolio for each year. So for each year, it would sort stocks or firms based on market capitalization. So this is the right way of doing it, at least in most of the research papers. Okay, so for now we were using Xstyle command or Xstyle function, which is a built-in function in Stata. So when you install Stata, this function would come built in. But one of the major limitation of this Xstyle command is that it is quite slow. And although we are using just a few observations, we have around 300 observations in your data sets, and in most of the asset pricing research papers data sets. The data sets are quite lengthy, and with Xstyle it would take quite a lot of time. So there is a way around, which is ASstyle. ASstyle is a user written command, so you would have to ssc install ASstyle. I have already installed it. So how this ASstyle command would work, we use the same syntax as we did above. So by sort year, we instead of egen we use ASstyle. We give in name to this new variable is equal to, we do not need to use this Xstyle function. We just give the variable name and then the number of portfolios. And let me also demonstrate over here that both these commands, whether you use Xstyle or use ASstyle, these both would produce exactly same portfolios. And again, to demonstrate this idea, I'm going to count if there is any observation, the number of observations that are not equal to, so there is any difference in these two variables, so there are none. So that proves that whether we use ASstyle or Xstyle, they both are going to produce same results. The added advantage is that ASstyle is fast and you do not need to install egen more to use by sort. So these are two added advantages. So let me just drop these additional variables that we just created, and let me just keep a style portfolio. So now we have portfolios, and what we need to do, we have made these portfolios based on market capitalization. Now we need to calculate equal weighted return. So by sort, for each portfolio each year, we are going to generate a variable EWRET, that stands for equal weighted return, which would be the mean of our RI variable, right? So that would be our, so for each portfolio each year, we have the same return. We would collapse this data later on, but for now we keep it this way. So, okay, so we might be interested in value-weighted portfolio return. For that, we need weights. And how do we calculate weights? We calculate weights based on market capitalization. So first we need to take a total of market capitalization for each year and each portfolio. So by sort, each year, each portfolio, we generate total market capitalization, which would be equal to total of, or this total is the function that is used to create sum. So total or sum of market cap variable. So this would generate a sum of market cap for each portfolio each year. This is how it looks like. So for each portfolio each year, we have the same total market capitalization. And then we are going to generate weight, and weight would be that specific years, that specific firm's market cap divided by total market cap in that portfolio in that specific year. So that would be generate value weight is equal to market cap divided by total cap. So this gives us weight. So this says that in 2015, this firm ID 14 had 24% weightage in first portfolio number 1. Now we need to multiply the return with the weights. So we get weighted return. And then we need to sum these returns across each portfolio each year. So we are going to, for each portfolio each year, we are going to generate a variable called value weighted return. That would be the sum of this temp variable that we just created. So now we get value weighted returns, right? So we have equal weighted returns and we have value weighted returns. But again, there are repeated observations. So what we do is we just bring the data down to portfolio level. And what we do is for each portfolio each year, just keep a single observation. So now we have around 60 observations. That is because we have 6 years of data and 10 portfolios. That is 10 into 6, 60 observations. So we have equal weighted return and value weighted return for each portfolio each year, right? So from here on, we have second portfolio. From here on, we have third portfolio's equal weighted return and value weighted return. And you might want to drop these additional variables. So that was the basic idea of how to generate, create portfolios and generate portfolio return. Sometimes certain papers would use certain percentiles rather than equal deciles. So let me just open the help of Xstyle. So we have PS style, which stands for percentile, and we have Xstyle, which stands for quantiles or deciles. So we can generate percentiles using PS style command. So what we are going to do is in certain papers, what they have done is that they have created two portfolios based on size, that is market capitalization. And what they do is that stocks below 80 percentile would become small stocks, or stocks greater than 80 percentile would become large or big stocks. So what we are going to do is, for each year we are going to generate a P80 variable which would contain the percentile of market capitalization, and which percentile we need 80th percentile. So this won't create portfolios, but this would give us for each year, right? For each year, it would give us the 80th percentile value. And what that would help us with is that now we can create portfolios. So for each year, what we need is we need to create a size variable that would be equal to small if market capitalization is less than 80th percentile, right? So these stocks have market capitalization less than 80th percentile, so they become small stocks. And then replace whatever the missing values are with the word big. So now we have these small and big portfolios, right? And if we want, we can again create value weighted or equal weighted return for these portfolios. Okay. Again, there is a concept which is called single dimensional or one dimensional versus two dimensional sorting. So whatever till now we had been doing is that based on a single factor we were creating portfolios, but sometimes we would want two-dimensional portfolios. So in most of the cases, what they do is they first sort based on size, and they make two portfolios, and within those two portfolios then they sort based on book to market ratio, and that intersection of size and book to market ratio would generate 6 portfolios, right? So small, low book to market, small, medium book to market, and so on and so forth. So let me get a fresh copy of this data. We again have that data set. So this time let's create again a portfolio based on market capitalization, but now we just have two size portfolios. So we have a small portfolio and a big portfolio. And now we are going to do two-dimensional sorting, and what that would mean is that for each size, so for each value in portfolio A-style underscore portfolio 1, and each year we are going to create BM portfolio, which would be based on book to market ratio, and we would have 3 portfolios based on book to market ratio. Okay. So now you can see is that if I would just sort on the basis of year, size and book to market, then the idea would be more visible. So for each year we have small portfolio, right? This is small portfolio, and within small portfolios we have 3 further subcategories based on book to market ratio. So basically we have 6 portfolios with the intersection of size and book to market. Again, we can create the equal weighted or value weighted return, and that would be by sort the size portfolio, the book to market portfolio, and each year. So for each size is book to market, and each year we need to generate equal weighted return, that would be the mean of stock return. And again we would have duplicate returns, so we need to convert that at portfolio level. So for each size, book to market, and year, we need a single value, and so that would give us these values. This was a basic idea regarding creation of portfolios and generating value weighted and equal weighted returns. Portfolio creation and working with portfolios is quite an advanced topic. So do let me know in the comment box below if you are interested in a particular area related to asset pricing model, and we would come up with a video on that topic. So thanks for watching this video, and do subscribe and do hit the bell icon.